We're often asked about melting point trends in ionic compounds as completely different from molecular compounds, which we're going to study next week. Ionic compounds, melting point trends can be explained strictly using Coulomb's law. And one of the best ways to think about this is to ask ourselves what happens in melting. So if we think about sodium fluoride, we're going to draw a lattice of sodium ions and fluoride ions. And I'm going to represent these with the anions larger than the cations, because we know now that that's the case. So this would be sodium fluoride solid. When it melts into sodium fluoride liquid, the distance between the ions increases. And we lose that structure that we had from the lattice. And what this overall does is it increases the distance between the positive and negative ions. Overall, we'll find that the distance is increased here. So the question is, which one takes more energy to increase this distance between the ions? Does it take more energy to do this for sodium fluoride or for magnesium oxide? And so let's draw ourselves a model for the magnesium oxide lattice. Which will look like that. And so then the question really comes down to which one is harder to separate, a +1 and a -1, or a +2 and a -2. Now, we know that what governs this is Coulomb's law. We know that Coulomb's law states that for two charged particles, Q1 and Q2, that the force is proportional to the product of the charges divided by the square of the distance. We know that this square makes the distance generally the more important consideration. So first thing we have to do is consider, well, how far apart are these ions relative to each other? And it turns out they're about the same because if we go to the periodic table, we see that magnesium and sodium are right next to each other, which means that Mg2 plus and Na plus are going to be about the same size. Mg plus will be a little smaller, but they're not going to be drastically different in size. The same thing is true for oxide and fluoride, because they're right next to each other in the periodic table, and their highest occupied orbitals are 2p. They'll be close in size to one another. Fluoride will be a little smaller because it has more protons. But overall, the ions involved in this are about the same sizes, so the distance between them in a lattice is going to be about the same. So that means we don't have to worry about distance. The only thing we have to worry about is the charge. The charge tells us that for sodium fluoride, which has +1 and -1, the product of those charges is -1. For MgO, the product of the charges is +2 times -2, which is -4. So Coulomb's law predicts that requires 4 times more force to separate the 2 + 2 - charges in MgO than it does to separate the +1 - 1 charges in NaF. And the greater the amount of charge for the ions in MgO explains the greater melting point for NaF. So basically what this is it is an applied test of whether or not you understand Coulomb's law. In order to melt the ionic solid, the ions have to increase in distance. The question then is which one is harder to increase the distance for? +2 - 1 charges, +1 - 1 charges, or +2 - 2 charges that are about the same distance apart.